For example, let us start from this molecule. So this is what type of representation? We know that this is wedge dash representation, right? Wedge dash representation. For example, convert that wedge dash representation into Fisher. How we are converting that wedge dash representation into Fisher, and what is the procedure we follow to convert that molecule? First of all, you identify out of plane groups. What are the out of plane groups? Hydrogen and OH. These are the out of plane groups. And we know that COOH and CH3 in plane or out of plane. CH3 and COOH are in plane. According to wedge dash, thick wedge is given above the plane, nearer to observer or front of plane. Broken wedge is given below the plane, away from the observer or back of plane. Okay, right. If groups are connected by normal lines, they are said to be in plane arrangement. COOH and CH3 in plane or out of plane, they are in plane. Okay, in plane groups, first you arrange like this. Now in case of in plane groups, top position COOH and bottom position CH3. Next you think about that H and OH. Now here in case of H and OH, in wedge projection, first you stand in between H and OH. That is very important point. We are standing in between H and OH. Now this is my position, or observer standing in between H and OH. Okay. According to this person, now this observer looking that molecule from right side or from left side. For example, if you are taking observer from left side, now this is the left side position. But according to this molecule, always in the conversion of wedge to Fisher, you stand in between out of plane groups. What are the out of plane groups here? H and OH. That's why we are standing in between H and OH, out of plane groups. According to this person, okay, first of all, now this OH is front of plane or back of plane. My plane is vertical plane. Simply here this OH is front of plane or back of plane, front side, and this one back of plane, back of plane. Okay, back of plane. OH front of plane and hydrogen back of plane. For example, if you are standing from right side, front of plane nothing but now onwards. Now you imagine like this. This is my plane and I am the observer. This is vertical plane or horizontal plane? Vertical plane. This is vertical. For example, if you are writing on the paper, that paper is taken as horizontal plane. But here I am writing on the digital board. Now this board is my vertical plane. Okay. So according to this vertical plane, this OH is front of plane or back of plane? Front of plane. And this hydrogen is back of plane. And this is my position. I am looking this molecule from right side. And where I am standing? I am standing in between out of plane groups. With respect to myself, this OH front of plane nothing but that is left side or right side? That is left side for me, and hydrogen right side. So I am taking like this OH group left side and hydrogen right side. That is the way of converting wedge to Fisher. Come to next example. Once again wedge is given. What is the first important condition? Now you should stand in between out of plane groups. That is the position of observer. After that, first you write one vertical line and one horizontal line. Why? Because here one asymmetric center is present, or three carbon atoms are there, like 1, 2 and 3. That's why I require one vertical and one horizontal line. First you fix the groups COOH and CH3. COOH and CH3. Top position and bottom position we are taking in plane groups. Clear? In plane groups. What are the in plane groups here? COOH and CH3. These two are the in plane groups. First we are arranging in plane groups on the vertical line. COOH and next one CH3. Next, what about out of plane groups? Now how I am looking this molecule from right side. And what about this OH? OH is front of plane or back of plane? This OH is front of plane. Front of plane. And hydrogen back of plane. Clear? Hydrogen back of plane. For example, if you stand from right side and just you observe this molecule, but what is the condition? You should stand in between out of plane groups. That's why I am taking arrow here. According to this person, this OH front of plane nothing but this is the front side. Now with respect to this person, OH is right side or left side? Right side. Now here OH right side and hydrogen left side. Whenever one asymmetric center is present, that is the way of converting wedge into fissure. So at the time of converting wedge to fissure, in plane groups we are taking like this, top and bottom, and always we are standing between the out of plane groups hydrogen and OH. These two are the out of plane groups. OH is front of plane, hydrogen back of plane. According to this person, OH front of plane nothing but just in front of the board. So right side or left side? Right side. That's why OH right side and hydrogen left side. Okay, clear. Come to next example. Here Sahars is given. How to convert Sahars into Newman? Sahars into Newman. So now in case of Newman projection, how we represent carbon atoms? By dot and circle. This is my front carbon atom. Next this is my back carbon atom. In case of Newman, front carbon atom represented by dot, back carbon atom represented by circle. Let this is the front carbon atom and this one back carbon atom. What is the given molecule? In which form that is given? This is Sahars. Why it is Sahars? Now in case of Sahars, we are taking diagonal like this. You can see both carbon atoms. Vertical fissure, diagonal Sahars, and sometimes they are giving horizontal also, no problem. But in case of Newman, one carbon atom, front carbon atom should be represented by dot and back carbon atom represented by circle. Clear? Now this is my front carbon and back carbon atoms. What is the angle between these two? CH3 and C2H5. What is angle between these two? They are looking like parallel. Okay, at front carbon atom, what I am writing? At front carbon atom, downside, methyl downside. Same thing you write here, CH3. And which is right side? Chlorine. Which is left side? Bromine. Same thing here you write, chlorine and here bromine. That is the arrangement of atoms and groups at the front carbon atom. Okay, just below, right, left, that's it. After that, what is the angle between CH3 and C2H5? They are looking like parallel or not? Yes, they are looking like parallel. Let it is the back carbon atom. Okay, this is my front carbon, and this one back carbon atom, okay, right. Next one, how to arrange bonds or atoms and groups on back carbon atom? What is angle between CH3 and C2H5? 0 degrees. That's why here these two are eclipsing to each other. Next one, bromine and deuterium. They are looking like same side or opposite side? Same side. That's why here deuterium and bromine, these two are eclipsing together. 0 degrees bond angle. Next, what is the bond angle between chlorine and fluorine? Same, 0 degrees. That's why here I am going to take fluorine. That is a way of converting Sahars to Newman. Very simple. Come to next example. Again Sahars is given and in which form they are asking? Newman. Okay, for Newman take front carbon atom as dot and back carbon atom circle. Clear? Now at front carbon atom, what is the position of methyl? Methyl just above or below? That is looking like above or below? Above. Same thing here you write like this, methyl above, CH3. Phenyl looking like right side or left side? Right side. Here simply write like this, right side phenyl and left side hydrogen. That is the arrangement of groups on front carbon atom. Any problem? Right. Next one, come to back carbon atom. This is my back carbon atom. What is the appearance of COOH from back carbon atom? Just below. Simply write like this, COOH at back carbon atom. Next, what is the arrangement of chlorine? That is looking like right side, chlorine, and here deuterium left side. No one is eclipsing. Why? Because CH3 above and COOH below. There is no 0 degrees bond angle. That's why I am taking here CH3 above and COOH below. Once again come back to front carbon. This is my front carbon. This one looking like top, pH right side and hydrogen left side. Same thing I am taking here CH3 just above, phenyl right side and hydrogen left side. Next from back carbon atom COOH below, COOH below, chlorine right side, deuterium left side. Okay, clear. Come to next example. Here which is given, Newman given. How to convert Newman into Sahars? Very simple. You can take either diagonal or simply horizontal. That's not about problem. Okay. First of all, let it is a front carbon atom. Again here it is the front carbon atom. What about pH? Just above. Simply write like this, pH, and just like Y form. Here which one we are taking? Phenyl. And the right side, which is present right side? Hydrogen. And which is present left side? Chlorine atom. Okay. And come to back carbon atom. Now this is my back carbon atom. At back carbon atom, what is the appearance of COOH? Just down. Simply write like this, COOH. Next here you write in the form of Y. Okay. And which is right side? Methyl. Simply write like this, methyl. And left side? Deuterium. That is the way of converting Newman to Sahars. Newman to Sahars. Yeah, next one. Again, Sahars is given. How to convert that Sahars into Fischer? Very important. Here you remember one point. Fischer is always fully eclipsed. Fully eclipsed. Very important point. Any form is given. If you want to write that given form into Fischer, you remember one point. What is the arrangement of atoms and groups in Fischer? That is fully eclipsed. Okay. Yeah, here Sahars is given. How to convert that Sahars into Fischer? How we are taking in Fischer? One vertical line and more than one horizontal lines. One or more than horizontal lines. Okay, clear. So according to Golden Fischer, for example here CH3COOH groups are there. Which is more oxidizable group? COOH. You better to take that more oxidizable group at the top of the vertical line. And what is the bottom position? CH3. Why we are taking like this? Don't get confusion. Already we know that what is the bond angle between top and bottom groups? Not 180. Once again I am repeating same point. In case of Fischer, they are looking like 180 angle of separation. But in the real molecule, what is the bond angle between top and bottom groups? 0 degrees. Now these two are looking like parallel. What is the bond angle? 0 degrees. That's why COOH and CH3. What is bond angle between these two? 0 degrees. Here at this carbon atom, hydrogen right side. Here also same thing you write, hydrogen right side. And what about deuterium left side? What is bond angle between chlorine and hydrogen? 0 degrees. Both are eclipsing together, chlorine and hydrogen. That is the way of converting Sahars to Fischer. Any form is given, either Sahars, Newman, Wedge, whatever it may be. If you want to write Fischer, what is the condition? Fischer is always fully eclipsed form. If it is not in eclipsed form, first to convert into eclipsed form, then only you write the Fischer form. Okay. But luckily here eclipsed form is given. Directly we are converting that Sahars into Fischer. Yeah. Come to next example. Is it eclipsed? That is not eclipsed. Why? Because here totally how many carbon atoms are there? 4 carbons. I am going to start from here. First carbon, second carbon, third carbon, and from phenyl I am taking 1 carbon atom. Totally we have arrangement of groups like this. Okay. Now here just you look at bond angle between COOH and pH. What type of bond angle is there? 180 degrees. But what they are asking? Fischer. What is the important point? From any form, if you want to convert into Fischer, what is the condition? Fischer should be always fully eclipsed. That's why whatever the molecule given, like Newman, Sahars, whatever it may be, first to convert that molecule into fully eclipsed form. Then only you convert that molecule into Fischer form. So how I am converting this molecule into fully eclipsed? Here I am taking like this. I am not going to disturb one carbon atom according to that given molecule. Here I am trying to keep phenyl, hydrogen, next one here chlorine atom. You can select any carbon atom. Again, there is no restriction, but the only thing is just you bring that molecule into fully eclipsed form. Here I am trying to rotate this front carbon atom. Here I am going to rotate with 180 degrees angle. If you are rotating with 180 degrees angle, what is the position of COOH after rotation with 180 degrees angle? Just exactly coming to opposite direction. And what about deuterium? This is the position of deuterium and this is the position of tritium. So what we are doing here, now this carbon atom, this carbon, I am rotating with 180 degrees angle. Rotating with 180 degrees angle. Okay. After rotation with 180 degrees angle, either in clockwise direction or anti-clockwise direction. What is the main aim of this rotation? Just I am trying to keep carboxylic acid and phenyl with 180 degrees 0 degrees angle of separation. How it is possible? Only after rotation with 180 degrees angle. For example, if you want to rotate this carbon atom, yes, you can rotate. That is not a what problem. But the only thing is bring the given molecule into fully eclipsed form. Next, after that, convert this molecule into Fischer. Yes, one vertical and two horizontal lines are there. Why? Because here two carbon atoms from here. This COOH I am taking here. Then which is eclipsing with COOH? Eclipsing with COOH is phenyl. What is bond angle separation between COOH and phenyl? 0 degrees bond angle. Yeah. Come to remaining groups. Here hydrogen just looking like right side and here deuterium right side. You can write like this: hydrogen and deuterium. These two are eclipsing. And come to tritium and chlorine. Tritium and chlorine. Here tritium, next one chlorine. That is the arrangement of groups. Okay. That is the way of converting Sahas to Fischer. Clear? Yeah. Next example, which is given Fischer to Sahars. These are very simple. Only when you are converting into Fischer form, that is the main important thing. There we should take the molecule in completely eclipsed form. In other things, very simple. Yeah, here which molecule is given? Fischer is given. Just you select. This is the front carbon atom and this is the back carbon atom. Now here simply you take like this diagonal. And Fischer is always fully eclipsed form. That's why you can take like this bond and bond, just you convert into Y form. Okay, right. Here first I am taking C2H5. Yes, C2H5. And which is eclipsing with C2H5? CH3. Same group here you write. Okay. Next one, hydrogen and bromine eclipsing together. Hydrogen and bromine. Left side chlorine and hydrogen. These two are eclipsing together. Okay. That is the way of converting Fischer into Sahars. Fischer into Sahars. Hydrogen and bromine eclipsing. Next one, chlorine and this hydrogen eclipsing. Come to next example. Fischer given. Again they are asking what? Sahars. Same thing. You can write like this also, no problem. Sahars form. In Sahars form, if you are converting from Fischer to Sahars or Fischer to Newman, always that should be what? Eclipsed form. That's why I am taking parallel lines. Okay, downside. Next, how to arrange the groups? For example, if you are taking here CHO, then what about right side group? That should be what? COOH. Next one, at CHO carbon, hydrogen right side and chlorine left side. Next, at this carbon atom, bromine right side and hydrogen left side. Okay, that is a simple way of converting Fischer to Sahars. Next one, Newman to Fischer. How to convert Newman to Fischer? Whenever Fischer is given, remember this point, that should be what? Always fully eclipsed. But here also eclipsed form is given. What is the angle between these two? 0 degrees. 0 degrees, again here also 0 degrees, no problem. Just here you write one vertical and two horizontal lines. Let this is the front carbon atom. So at front carbon atom, what is the orientation of CH3? Just downside. And which is right side? Bromine. And which is left side? Hydrogen. Come to back carbon atom. At back carbon atom, ethyl group is present. What is the angle between these two? 0 degrees. Methyl and C2H5. What is the angle between these two? 0 degrees but not 180. From front carbon atom, bromine, back carbon atom, chlorine. These two are eclipsing together. That's why here chlorine, and which is here deuterium. That is the way of converting Newman to Fisher. Okay. Come to next example. Here Newman is given, and in which form they are asking? Fisher. How it is possible to convert? Already you know that whenever if you want to convert into Fisher form, Fisher is always fully eclipsed, but here this is not eclipsed. Okay, convert into fully eclipsed form just by rotating with 180 degrees angle. I am not going to disturb this front carbon atom. Okay, here at front carbon atom there is a phenyl group. Next one here chlorine and hydrogen. Just rotate back carbon atom. If you are rotating back carbon atom with 180 degrees angle, rotation of back carbon with 180 degrees angle, back carbon. Then what is the position of your COOH? This is the position of COOH. Next one, left side bromine and right side hydrogen. This is fully eclipsed form. Okay, right side fully eclipsed form. Then you convert into Fisher, one vertical and two horizontal lines. For example, if I am taking here pH, then what is exactly at the top of the vertical line? COOH. Here chlorine and hydrogen eclipsing. Chlorine, hydrogen eclipsing. Okay, right. Next, hydrogen. At front carbon atom hydrogen, back carbon atom bromine eclipsing. That is the way of converting Newman to Fisher. Whenever you are converting into Fisher form, first you convert that molecule into fully eclipsed form. Then only finally you write Fisher form. Okay. Next example. Newman. How to convert into Newman? Very simple. Let this is the front carbon atom, front carbon, and this one back carbon. Okay. Front carbon atom represented by dot, back carbon atom represented by circle. And how to arrange groups at front carbon atom? First you write like this. Phenyl below. Here also you write below. Right side bromine, which is left side hydrogen. Clear. After that, how to arrange at back carbon atom? What is angle between phenyl and phenyl? 0 degrees. Here also you write like this. Phenyl and phenyl eclipsing. Next one here hydrogen and hydrogen eclipsing. Next one bromine and bromine eclipsing. That is the way of converting Fisher to what? Fisher to Newman. Okay, clear. Next example, again Fisher to Newman, same part, same thing. Here let this one front carbon atom and this one back carbon atom. In Newman projections we are taking front and back carbon atoms. Okay, at front carbon atom, which is downside phenyl, which is right side hydrogen, which is left side bromine. Now we should maintain 120 degrees bond angle between any two bonds. And phenyl eclipsing with what? CHO. That's why here you write like this, CHO. Okay. Next one. Front carbon atom bromine, back carbon atom deuterium. These two are eclipsing together. Next one here hydrogen and chlorine eclipsing together. That is the way of converting that Fisher to Newman. Fisher to Newman. Yeah, next one. Wedge to Fisher. That molecule looking like lengthy but very simple, no problem. The only thing you remember, thick wedge given. Front of plane or back of plane? Front of plane. and broken wedge is given. That should be what? Back of plane. That's enough to convert into Fisher form. So here wedge representation given. I am going to convert into Fisher. I want some space. 1 second. Yeah, this is the given molecule. Directly, if you want to write in golden Fisher form, how to convert into golden Fisher form? First of all, here extremely left and right side groups are there. First, you look at extremely left and right side groups, CHO and CH2OH. So what I am going to take here, CHO at top position, CH2OH at bottom position. I want to keep more oxidizable group at top position and remaining bottom position. That is the first important thing. Don't get confusion, very simple. First of all, we are looking towards extremely left and right side groups. Who is present extremely left side? CHO. And who is present extremely right side? CH2OH. Which is more oxidizable group? CHO is more oxidizable group. That's why we are taking CHO at top position and CH2OH bottom. After that, how many carbon atoms are there? 1, 2, 3 and 4 carbon atoms are there. We require how many horizontal lines? We require how many horizontal lines? 4 horizontal lines we require. 4 horizontal lines. Okay, clear. Now, at each carbon atom, just only one wedge representation given. Examination point of view, just they are giving like this. But by default, which is the fourth valency? Even though they are not giving, by default, what is the fourth valency? Hydrogen. Is it clear? Fourth valency should be hydrogen. Here OH given from back of plane, and what about hydrogen stereochemistry? Front of plane. Next one, OH given from back of plane. Then what about hydrogen stereochemistry? Once again, OH given from front of plane. What is the hydrogen stereochemistry? Back of plane. Next one, already here two normal lines are there. One is given from back of plane. Then what is the stereochemistry of hydrogen? That should be taken as front of plane. Clear? Actually, hydrogen atoms are not given. By default, we are taking hydrogen atoms according to the fourth valency, right? How we are looking this molecule? We are looking this molecule in this direction. For example, now this is the position of observer. Just imagine like this. That is the position of observer. This is the given molecule. We are looking this molecule like this. But conveniently, what I am doing here, at each carbon atom to arrange the groups, just I am standing in between these two out of plane groups. And come to this carbon atom, just you stand in between these two groups. Again come here like this. Next one, that is the position of observer. Whenever you are converting wedge to Fisher, what is the important thing? Always you stand in between out of plane groups. Okay? Yes, no problem. This is our CHO. Come to this carbon atom. How to arrange groups? According to this person, this OH front of plane or back of plane? Front of plane. Front of plane. That means left side or right side? Left side. Simply here you write like this. This OH left side. And come to this carbon atom. Now at this carbon atom, what is the position of hydrogen? Position of hydrogen. Just you stand in between these two carbon atoms. Hydrogen front side or back side? Hydrogen front side and OH back side. If you stand in between these two, OH appears right side. Sorry, hydrogen appears right side. Now this is the hydrogen. This appears right side. Next, what about OH? OH left side. OH left side. And come to this carbon atom. Just you stand in between these two. What is appearance of OH? Front of plane. Front of plane nothing but with respect to this person, this one left side or right side? Left side. Here I am taking this OH left side. Okay. Next one. If you are standing in between these two, hydrogen front of plane. Hydrogen front of plane nothing but that should appears right side. And what about OH left side? Okay. Arrange remaining hydrogen atoms. Hydrogen, hydrogen, here hydrogen and hydrogen. That is a way of converting wedge to fissure. OH left side, next one here OH left side, OH left and OH left. Okay, clear. Next example. Now this is the given molecule. Here top CHO. Yes, here I am going to write CHO. Okay. Next one here in plane OH is there. Same thing here you write like this OH. After that, if you want to write groups at this carbon atom, just you stand in between these two. Okay. This hydrogen from this direction, in this direction, hydrogen front of plane. That means right side or left side? Right side. Here hydrogen right side and chlorine left side. Next come to this carbon atom, just you stand in between these two. Okay. Chlorine front of plane or back of plane? Chlorine front side. According to this person, chlorine front side nothing but just front side. That means left side or right side? Left side. Chlorine left side and bromine right side. And come to this carbon atom. Here this is the position of observer. Always observer should stand in between out of plane groups. So according to this person, chlorine front of plane or back of plane? Front of plane. That means right side or left side? Right side. Chlorine right side and hydrogen left side. Last one. This is the position of observer. Okay. Standing like this. With respect to this person, bromine front of plane. That means left or right side? Left side. So bromine left side and hydrogen right side. Okay. This is the way of converting wedge to fissure.